Hey everybody, in this video we're going to evaluate a piecewise function, and our function is f of x is equal to 4x plus 4 if x is less than 0, and 3x plus 5 if x is greater than or equal to 0. We're going to start with f equal to -1 here, so f of -1 is less than 0, so it's this top case is 4 times -1 plus 4 is -4 plus 4 is 0. So f of -1 is 0. Okay, let's take a look at our next case right here. 0. Well, 0 is greater than or equal to 0, so it falls into this second row. So we're going to take a look at f of 0. That'll be 3 times 0 plus 5, which is 5. F of 0 is equal to 5. And then let's also take a look at the last point right here, 3. 3 is greater than 0, so that's also the second case here. F of 3 is equal to 3 times 3 plus 5, which is 9 plus 5, which is 14. So f of 3 is equal to 14. Great. And that's evaluating a piecewise function. Let's take a look at an example from a book. The example wants us to take a look at this piecewise function. F of x is equal to 3 if x is less than 3, -3 if x is greater than 3. Oh, pardon me, less than or equal to. This is going to be important. We want to find the graph, range, domain. So it says that the domain is R. It's all real numbers, that's our domain. And our range, though, which is the nice, interesting bit of piecewise functions, let's make that look like a calligraphic script, R, is actually just the set 3 or -3. Those are the only two outputs we get. It's not like an interval or some sort of continuum, it's just these two discrete values. And as for which is which, greater than 3 is 3. This is greater than right here. So this one's in, that one's out, that one's out, this one's in. And I think the big question right here is filled circle versus hollow dot. And f of 3 will determine that. F of 3 is 3, right? It falls into this top case. 3 is less than or equal to 3. So it's this one B. It's not this hollowed one, it's B. That's our graph. Great.